Assalamualaikum and hi to Madam Farah Yasmin. So today I'm Haris Murshidi bin Maisa. So I want to present, I want to share, I want to explain about Lab 1 ECE521 Assembly Language Programming for data transfer, data processing and also addressing mode. So before we start this lab, so we need to see the learning outcome, which is the objective for this lab is we want to write the simple assembly language program for ARM microcontroller using data transfer, data processing instruction and also addressing mode. And the second one is we want to execute the program using ARM Kyle editor, assembler and also the simulator. So without wasting time, let's go to the question 1. Based on the question 1, which is we need to write a program that will store 0x30 into R0, which is we need to store into the register. And then after that, we need to copy the content of R0 into R5. What the content in the R0 copy to the R5. Then save the data, okay? Save the data 0x45785612 into memory location, okay, into the memory location 0x40000030, and then execute the program and explain the difference, what happened, what is the changes in this program. Before you start to write your program, before you start to run, to execute your coding, your program, don't forget to start your coding, your program with assembler directive, which is area, my program, code, read only, export, main and entry. And then your coding will start after this main instruction. Okay, so and don't forget to end your coding, end your program with again, branch again, and then end. Okay, so before you start, before you want to build your program, you need to check first your option for target. So you need to make sure the use simulator is already ticked, and don't forget to insert this file with debug file. Okay, so after done this, you need to check that this manage runtime environment. Okay, you need to make sure this is Nucleo, and then the CMSIS is already ticked at core, and also device already ticked at startup. Okay, this step you need to done first before you start your programming. So we want to check what is the changes happen in this coding. So we just build this program. Okay, we click build, and then 0 error and 0 warning. So to see what happened, what is the changes in this coding, in this program, we can just go to the debug session, okay, by click at this debug code, debug icon. So what we need to do is click at after main, and then we click at run to cursor line, and then we click at this assembly, and then we can just go step. Alright, so for the first one, MOV R0 0x30. It means what? Why we use MOV? Because MOV is 8-bit. We also can use LDR, but yeah, depends on the programmer. So for MOV instruction, this is immediate addressing mode. So when we run this program for MOV, so we can see that R0 will store 0x00000030. Okay, the question asks to copy the content in R0 into the R5. So in R5 will become same, which is 0x00000030. Okay, and then we just click step, and we can see the value in R5 is same with R0. And then LDR. Instruction of LDR is just same with MOV, but LDR is 32-bit. Okay, so what will happen in this instruction? LDR R1, which is we load the register R1 with this value, which is 0x40000030. It means what? In R1 will have this value. So we just step, and we can see in R1 will store 0x40000030. And then same goes to this step, to this line, which is in R2 will store with the value 45785612. And these two instruction, both instruction is immediate addressing mode. So after that, this line str, which is we store what the content, what is the data in R2 into memory R1, content of memory R1. It means what? After we click step, so in R2 now, what is the value in R2? So in R2 we have 45785612. Oh, it means what? This value will store in the content of memory R1. So where we want to check, we can check the value in the memory table. Okay, so we just search the address, which is 0x40000030, which is the R1 value. Okay, so we can check in this memory, in this address, we have the value of 12, 56, 78 and 45. We can see that the value, the content in R2 will store in the content of memory R1. So for str instruction is indirect addressing mode, immediate offset. Okay, so after done this program, don't forget to again branch again and end. So done for question 1. Alright, so next for the question 2, write and execute the program that will add, okay, addition 0x20FE5690 0xFE123089 and also 0x34585710, and then save the sum, okay, the sum in the register R7. So record the changes in CPSR. So we want to check the CPSR, which is the flag as well. Alright, so let's go to the coding, to the program Q2, question 2. Alright, so this is my program. So after write the assembler directive, I start my program with LDR, load register R0, R1, R2 with all the value in the question. Alright, to see the changes, what happened in this program is we just click after main LDR and then run to the cursor line, and then we just click at the DSMD and then just click on step. Okay, so the first step is R0 and then R1 and R2. We will load all of this value into this register. Alright, so we just step 1, the content will insert in the R0 and then we'll insert in the R1 and we'll insert in the R2. Okay, and then the instruction is we need to add, okay, addition, the value of the value in the R0, R1 and R2. We can refer on the instruction for addition instruction. We can use this one, which is SD is the direction, SN and also SM. So we can see that we can just only add two only register. So what we need to do is we need to add the first two register and then we add the last register. On these cases, so we use ADDS because why? Because we want to see the changes in the CPSR, the flag. For ADDS R3, R0, R1, it means what? It means R0 will add with R1 and then save into the R3 first. Okay, so we can just only add two register. So we click step. So we can see that in R3 now we have 0x1F108719. So how we want to prove this is true? So we can just check on the calculator. So we open the calculator, R0 and R1. So we can see it. The value is 1F108719, which is same with the content in R3. So what is this? What is this one in front of this number? So this one is referred to the carry. It means what? The carry will become 1. Let's check in the cal. So let's check. So based on the cal, we can see that C, the carry, is equal to 1. Okay, so because of why we can see the changes in CPSR because we use ADDS. If we remove the S instruction, so the program will ignore the CPSR. Alright. So after that, the content is in R3 is the addition with R0 and R1, and then the last register we need to add is R2. It means what? For the last instruction, ADDS, R7, R3, R2. It means what? The R3 will plus with will add with R2 and then save in the register 7, same like the question. Alright, so after we step, so we can see the R7 now is 0x5369 1E29. Is it true? Let's check to the in the calculator. Alright, so this is the value that we already add before this, and then add with the register R2. So we can see the result is 53691E29. So is it true that this number, this value will add in the register R7, same like the question? Alright, so for question 3, write a program that will store 0x2936FEDA in register 8, and then perform the following instruction on the content of that register 4 times. Comment on your results. Okay, so we already store, okay, this content, which is 0x2936FEDA in register R8, and then we will done the ASR, LSL, and also ROR. So what is ASR? ASR is arithmetic shift right, LSL is logical shift left, and ROR is rotate right. So we need to load in the register 8 with this value 0x2936FEDA. So we step, and the register R8 will store this value. Okay, and then ASR, arithmetic shift right. Arithmetic shift right, the R8, okay, arithmetic shift right R8, what is the content in the R8, and then we store it into the R7. And then the question said that we need to perform the instruction 4 times. That's why we use this hashtag 4, which is we need to do it 4 times. Okay, so after we done, so we just click step. Okay, step, and the content in R7 is 0x02936FED. So how the ASR instruction works? Okay, so to run this program, to understand how this instruction work, we need to convert the register R8 to the binary. Okay, so after we convert to the binary, we will arithmetic shift to the right. Okay. So after we convert the register R8 with the binary numbers, so we can see that all of these binary numbers is refer to the number hexadecimal in register R8. So how the arithmetic shift works? So arithmetic shift right, it means it will shift the numbers, the binary numbers to the right. So remember that based on the question, we need to ASR 4 times. It means what? We will ASR 4 times, which is the 4th turns, the 4th numbers. So we can see that 0010 we will start to shift after 4. Alright, so these numbers 0010 will become like this at the 4th. Okay, this one is the 4th, will become 0, and then we will start the 0010 at the turn number 4. So we can see after we shift 4 times, okay, to the right, and we will get this value, and it refers to this hexadecimal number 2936FED. This is same what we get in the register R7, which is 0x02936FED. Okay, so for the next instruction is LSL, which is logical shift left. So how LSL works? Alright, so after we convert to the binary, we can see 0101. Okay, these numbers we will put it, we will shift after 4, which is at this one, 0101. So what happened at this first hexadecimal numbers, 0000? In LSL, after we shift all the values, so the first places we will put it 0. Okay, so that is the rules. Okay, so after done, we shift all the values and we will get the value is 936 FEDA 0. We can see in register R6 we have 0x936 FEDA 0. So is it same what we get in the card? So next one, ROR, rotate right. So how the rotate right works? So for rotate right, the rules is like this. Okay, which is the last hexadecimal numbers, which is A, we will put at the first, and then we continue with carry, and then start with the content. Alright, so like this one, we can see that the last one, the last hexadecimal number is A. Okay, the last hexadecimal number is A, which is 1010. Okay, so we just put it right here, 1010. Okay, this is A, which is the last hexadecimal numbers, and then we continue with carry. In these cases, the carry we assume as 0. So 1010, we continue 0, like right here, 0, and then we just continue the numbers, which is 0010, and then we just shift until the end. So we will get the results, which is 42936 FED. So the register in R5, we will get A 2936 FED. So it is same what we get in the register R5. So next, for question 4, write a program that will perform a logical OR. Okay, logical OR with 0x6398 with 0x1DFE, and then execute the program. So what we can see here, we need to store this value, this content, in the register first. Okay, so like this one, we load register R0 with the content 0x6398 and R1 with 0x1DFE, which is a value is given in the question. And then we need to perform a logical OR. Refer to the ARM instruction. So to do the logical OR instruction is by using ORR instruction. Okay, so after we done by using ORR instruction, ORR R2 R0 R1, it means what? R2 is the destination, and then we will logical OR R0 with R1. Okay, we will store R0 with 0x6398, and then in R1 is 1DFE. Bitwise instruction ORR, what will happen? What will happen in register R2 is 7FFE. So let's check in the calculator. So we can check the content. The result is 7FFE, and it is same that happened in the register R2. The same value happened in the register R2. So for question 5, write a program that copy 12 bytes of data starting from memory location 0x40040000 HMIN hexadecimal to memory location starting 0x40040020. Okay, so we have two address here, and set manually the content of memory in 40040000 until 0x400400B. Okay, to be 01, 02, 03, and so on. After we enter the debug session, we need to enter the content of memory in 40040000 to be 01, 02, 03 and so on. So by click at the memory section here, so we just put 01, 02, 03 and so on. So after done, enter manually all the content of memory in this address, so we can start to run the program. So I load the register R0 with data 1 and load the register R1 with data 2. So what is data 1 and what is data 2? I already set in this section, which is data 1 is equal to for 004 0000, data 2 is equal to 0x for 004 0020. MOV move R2 with 3. Okay, so let's see this first section, LDR and MOV. LDR means we set the pointer of address, and then MOV R2 with 3, it means the counter. So next, LDR. So next for the LDR instruction, LDR R3 bracket R0 hashtag 4. It means what? LDR, what is the content memory of R0, we will save in the register R3. It means what? And this hashtag 4 is post index, we will take 4 places. Okay, so what is the content memory in R0? In R0 is for 0040000, like we can see in this memory section. So we have these numbers 01, 02, 03 and so on. So what will happen in this instruction, we will take 4 places, 4 content of memory, and we will save in the R3. We can see in R3 we have 04, 03, 02 and 01. So this hashtag 4 function is to take 4 places in the content of memory. So and then we load the str, store R3 R1 bracket R1 hashtag 4. It means what is the value in R3, we will store in the content memory R1. So before this, we take out the content of memory into the register, and then we store it again from the register to the content of memory, but in different address. The value in R3 will save in the content memory of R1, which is R1 is for 0040020. The content of memory is already changes, is already copied to the another address, which is for 0040020, which is the value is 01, 02 and so on, that we already set it manually before this. We subtract, okay, we subtract R2 with 1. So remember before this, we already set the counter, yes, with hashtag 3, and then we will subtract 1. So 3 minus 1 is equal to 2, and then we compare. So in R2 now have 2, and we compare, is it R2 is equal to 0? No, right? So branch not equal, so it will branch to lagi, and it will execute again the instruction before this. So after done 3 times, we copy the content from one address to another address. We can see that all the content is already copied to 40040020 with the content of memory 01, 02, 03 and so on. And then we run again the subtract R2. Okay, so now R2 is equal to 1. Okay, and then we subtract to 1. 1 minus 1 is equal to 0. Okay, so compare, is it R2 is equal to 0? Yes, so it will end the program. Okay, so next for the last question, question 6, which is write a program to compare data in num into register R2. Okay, so if data is greater than 5, okay, higher than 5, store the data in the memory location 0x for 002 0000. Otherwise, add the data with 0x60 and store it in the memory location 4002 0010. Okay, so before that, set the number with value of 3. So we know that we need to have something in num, and then we need something in R2. And also we have two address here, right? We have 4002 0000 and also 4002 0010. So what we need to do is we need to insert all of this value into the register first. So I put this value into the R3, R4 and also R5. So after we run, R3 will have this value for 002 0000, and R4, okay, R4 will have for 002 0010, and R5 will have 60. Okay, and then we move MOV R1 with number, with num. Okay, so what is the value in num? So I already said num EQU 3, which is the question asked to set the number with value 3. Use EQU instruction. In R1 we will have 3. Okay, and then move R2 with 5. Why 5? Why 5? Okay, so based on the question, if the data is greater than 5, it means what? We need to compare the num and R2. Okay, so R2 we will save the value of 5. Okay, so in R2 we will have 5 right now. So and then we compare CMP. By using CMP instruction, we will compare R1 and R2. So based on in these cases, in this program, I use BHI, which is branch higher. Okay, branch higher or greater than. Alright, so after done, compare. Okay, compare R1 and R2. It will check either R1 is higher than R2. Is it? So R1 is 3. R1 is 3 and R2 is 5. So is it R1 is higher than 5? No, right? So the instruction will ignore the greater jump. Alright. After you go to the ADD instruction, we can see on the question, add the data with 60 and then store in the memory location. Okay, and then what we need to do is R1 and R5. Why is it? So R1 plus add with R5. So R1 is 3 and then we will plus with R5, which is R5 is equal to 60. And then we store it in the R6. So we can see the content in R6 now is 63, which is what? 60 plus with 3, and it will result 63, and it will store in the R6 because this is the destination. And then what the question said, store it in memory location for 002 0010, which is R4. So we will use str instruction, store. Okay, the R6, what is the value in R6? We will store in the memory location R4. What is the R4 address? R4 address is 0x for 002 0010. Alright, so we can see in this address we will have 63. Okay, because we already store it in the memory location. Let's see if the number is higher, is greater than the 5. So let we change the value. For example, before this, the question asked to set the number with 3, right? So let's see if we change the numbers to what? Maybe 10. Yeah, we change to 10 and then we build. Okay, and then debug. In these cases, I already changed the number with 10. Okay, so now let's see. In this line, we compare R1 and R2. So R1 is 10 and R2 is 5. Okay, is it R1 is higher than R2? So the answer is yes, 10 is higher than 5. So when we run, it will jump to the greater. So where's greater? Greater this one. So it will str store the value in R1 into the content memory R3. Okay, so when we done, so let's see in the address R3 40020000. So we can see what is the content memory in 40020000. So the answer is 0A, is mean 10. So that's all for this lab 1. So hopefully it's clear and can to be understand. So thank you. Assalamualaikum.